Okay, today's lesson is going to be on graphing rational functions. We've already done several lessons on graphing rational functions, some with slant asymptotes, even some with quadratic asymptotes. So I just picked a couple more that I thought were kind of interesting that we should go through. So let's take a look here at graphing rational functions and starting off with the following rational function. So when graphing rational functions, the same idea, we want to go through the characteristics that we know. So, first, is there an x-intercept? You'll notice the top is never equal to 0. There's no value of x that's going to make that equal to 0. So this has no x-intercepts. If you're looking for a y-intercept, your y-intercepts happen when x is 0. So evaluate our function at 0, which gives us negative 2 over 9. So we have a y-intercept at negative 2/9. Right away, we see the degree of the bottom is larger than the degree of the top, so we have a horizontal asymptote at 0. You'll also notice we have vertical asymptote at x equals 3. So let's go ahead using this information and graph. So right away, I went ahead and sketched out my vertical asymptote and my horizontal asymptote. I'm then going to go ahead and graph my y-intercept, which happens around negative 2 over 9, so somewhere around here. And then we want to graph our function. So to graph this function here, again, focus our attention on our vertical asymptote and then ask ourselves, as we approach the vertical asymptote from the right-hand side, are we approaching negative infinity or are we approaching positive infinity? So in this case here, we're really not sure what we're going to do here. So what I'm going to do here is pick a number larger than 3 and evaluate that at our function, r at x. If it's positive, we're above. If it's negative, we're below. So evaluating the function, let's say at negative 4, we end up getting a negative number on the top and a positive number on the bottom, resulting in a negative number. So this will be below. Therefore, the graph will look something like this, and then we'll tend towards our horizontal asymptote. The same idea exists on the other side of the equation. As I approach my vertical asymptote from the left-hand side, if I was approaching from above, to hit this y-intercept, I would need to have a root here, which I do not have. And again, just to remind you, you can cross these horizontal asymptotes locally. Again, the horizontal asymptote was created only by letting x get infinitely large or infinitely small. That says nothing about x being locally some finite number. So therefore, it must be the case that it's coming from below, going up, crossing through our y-intercept, and then slowly tending towards our horizontal asymptote. All right, we have graphed our rational function. Let's take a look at another example. In the next example here, same idea, go through the characteristics of this rational function. So start off with your x-intercepts. Once again, this has no x-intercepts as we have no value of x in the numerator. That's going to make that 0. Y-intercept happens when you evaluate your function at 0, in which case we get a third. Vertical asymptotes exist when the bottom is 0. The bottom is never 0 here. X squared plus 3 will never be 0 for any real number that you square and add 3 to that, so we have no vertical asymptotes. However, the degree of the bottom is larger than the degree of the top, so we will have a horizontal asymptote at 0. So let's draw our graph. All right, I went ahead here. I graphed my horizontal asymptote at 0, and then I have my y-intercept. Again, there's not much else to illustrate on this graph here. Now, when we go to graph this, you'll notice that if you pick anything greater than 0 or less than 0, that this function here, r at x, is always greater than 0, right? So this function, r at x, is always greater than 0 for all x values that you choose. Any real number you choose, it'll always be the case that this expression will be greater than 0. So therefore, my function is always above the x-axis. It'll never be below. So this function will again tend up towards my y-intercept and then tend back down and get closer and closer and closer to that y equals 0 line, but never actually becoming that line. So you can see here quickly, I'm not sure if this is apparent to you, but you can see that this function is actually symmetric about the y-axis. This is an even function. And in case you don't see that, let me just show you quickly algebraically. An even function exists if r at negative x equals r at x for all x in the domain of, in this case, r. Well, you can see here r at negative x is going to equal 1 over negative x squared plus 3, which is 1 over x squared plus 3, which is r at x. So we have an even function here, and you can see that visually as well. It's symmetric about the y-axis, and this would represent even function. All right, let's take a look at another graph. We want to go ahead and find all the characteristics of our rational function. So x-intercept, this time we do have an x-intercept. The top is going to be 0 when x is 0. So we have a x-intercept at 0, and because of that, we have a y-intercept at 0. Vertical asymptote, we do not have any vertical asymptotes. Once again, this will never be 0, x to the power 4 plus 1. Horizontal asymptotes, this time the degree of the top and bottom are equal. And when the degree of the top and bottom are equal, you divide by the leading coefficient of the top, divided by the leading coefficient on the bottom, in which case we get y equals 5 as our horizontal asymptote. And now let's put this all together and graph. So I went ahead here and labeled our horizontal asymptote at 5 and our x-intercept at 1. So once again here, I know that my function has to tend towards my slant asymptote. We have to have this some sort of look like this to it. There isn't many options here in terms of graphing. It could be the case that possibly it goes above and then goes back down, goes above and then goes back down, or possibly does not cross that horizontal asymptote and looks like this. So in this case here, either way, you have a general basic shape where the function is approaching closer and closer to your y equals 5 line. And you can see here we have the following function. And once again, notice this is symmetric about the y-axis. And a quick check here, you'll see this is an even function as well. And just quick proof at the bottom here, just to show you it. It's fairly obvious, but you can see here r at negative x equals r at x. And we have ourselves an even function. All right, that concludes today's lesson on graphing rational functions. Thank you.